In this video, we're going to be looking at filling out tables. Our objective, understand what a table is. Understand how to fill a table out. Vocabulary, table, organizational tool used for data. Basically, we get some numbers, we put them in the table just to keep them in order. Makes life a little bit easier in the long run. There are two main types of tables we're going to look at. A vertical table. Typically you put your variables being used on either side. We usually go alphabetical. First one on the left, second one on the right, and then we just fill it in top down. Horizontal, we typically put the first one alphabetically on the top, second one on the bottom, and we fill it in from left to right. So now we need to kind of look at what we do with these. So I have two vertical tables and equations that go with. So we have y equals 2x plus 4. X on the left, y on the right, because x comes before y. We need to pick out which variable we're going to put numbers in for. Easiest thing to pick is to put numbers in for the letter that is actually being used in the math. So we have 2x plus 4. So the x is being used in the math. I'm going to put numbers in for x. I'm just going to pick them. I usually go with pretty easy numbers. 0, 1, 2, 3, and 4. So we go with very simple numbers. And then all we do is, this is like x equals 0. We're going to take 0, put it in for x. 2 times 0 plus 4. Then whatever we get for this will equal our y that goes in there. So, order of operations, 2 times 0 is 0, plus 4 is 4. So equals 4 equals y, so 4 goes in for the first situation. Then we just repeat this for every number that we've got. Sometimes it's 3, 4, 5 times, sometimes it could be more, sometimes it could be less. 1 goes in for x. 2 times 1 is 2, plus 4. 2 plus 4 is 6. So it equals 6, which equals y. So we got 6 for our second situation. Move on to the next one. 2 times 2 plus 4. 2 times 2 is 4, plus 4 is 8. So we've got 8 here. And continue on. 2 times 3 plus 4 is 6, plus 4 is 10. So we've got 10 for that one. And we've got one more. 2 times 4 plus 4. 2 times 4 is 8, plus 4 is 12. Now as you can see, a pattern kind of develops in the y's. If there's a pattern that develops, you can sometimes use that. It's just whether you can kind of tell that there is one. And also don't just assume there is a pattern right away. You've got to do a few numbers to kind of prove it first. Okay, a little bit tougher problem here. B has the numbers that's being math done to it. So we're going to actually pick numbers for B this time. So I'm going to go with 0, 1, 2, 3, and 4. Now these are easy numbers to use if there's no fractions in the problem. If there are fractions in the problem, we'll kind of talk about a way to make life a little bit easier for those. So now, when we get our answer, we're going to put it in for A. So 9 minus 3 times 0. Notice, multiply first. 3 times 0 is 0. Minus 9, bring it down. So 9 minus 0 is 9. So we put a 9 there. Move on to the next one. 9 minus 3 times 1. Oops. So 3 times 1 is 3. Bring the 9 minus in front, and we get 6. Okay? 9 to 6 is going down by 3, so we think it might be that, but we need to do a little bit more work before we can just rest on the pattern. 9 minus 3 times 2. 3 times 2 is 6. Bring down our minus sign and our 9. 9 minus 6 is 3. Okay, 9 to 6, 6 to 3. Let's do one more, make sure the pattern fills out, and if it does, we'll go to the next one without as much work. 9 minus 3 times 3. 3 times 3 is 9. Bring down our minus 9 equals 0. So 9, 6, 3, 0. Next one, most likely, negative 3. Okay, two more situations we're going to look at. One is with fractions. Best thing with fractions is this doesn't work all the time, but a way to kind of deal with fractions less is to count by the number that's in the denominator of the fraction. So here we've got a 2, so I would start with 0, just because 0 is easy. I'm going to count by 2's, so 0, 2, 4, 6, 8. Notice I went 0 in for the x because we're doing math to the x. I went by 2's because the denominator is 2. This will get rid of the fraction sometimes, but not every time, so don't think that it's a guarantee. 3 over 2 times 0 over 1. Remember, just put it over 1 and we got our fraction. Top times top, bottom times bottom. 0 over 2. Well, 0 divided by 2 is just 0. So this is 0 minus 1, which is negative 1. Okay, next problem. 3 over 2 times 2 over 1 minus 1. Top times top, bottom times bottom. We're going to get 6 over 2. Well, 6 over 2 divides out. It becomes 3. So I'm going to use 3 instead of 6 over 2. Makes life a little easier. 3 minus 1 is 2. Next version. 3 over 2 times 4 over 1 minus 1. So we're going to go 3 times 4 is 12. 2 times 1 is 2. 12 divided by 2 is 6. So we have 6 minus 1, which is 5. Anybody see a pattern yet? If you do, you could use it to fill out the rest. I'm going to do one more, make sure my pattern works. 3 over 2 times 6 over 1 minus 1. It's going to give us 18 over 2 minus 1, which is 9 minus 1, which is 8. Looks like we're adding 3 each time. It gives me an 11 there. And I have another table. Notice, by counting by 2's, we didn't have any fractions for any answers. We can still count by 1's. We'll just get some fractions here. And remember, counting by the denominator doesn't always guarantee we get rid of fractions. It's just a little trick that sometimes does. Our last situation is exponents. We really do this exactly the same. So we're doing math to the A. We're going to pick A's. 0, 1, 2, 3, 4. Okay, the reason I want to show you this is the patterns aren't as easy to figure out when there's exponents in the problem. So don't fall into the trap of always finding a pattern and just using it right away. 0 squared plus 2. So 0 squared is 0 plus 2 gives us 2. 1 squared plus 2. 1 squared is 1 plus 2 is 3. Notice 2, 3 looks like it's going up by 1. That's going to change here. 2 squared plus 2. 2 squared is 4 plus 2 is 6. Look, up 1, up 3. That's weird. So we got to look at the next one. 3 squared plus 2. 3 squared is 9 plus 2 is 11. Up 1, up 3, up 5. Might be a pattern that you guys can see now. 4 squared plus 2 is 16 plus 2, which is, 18 here. Alright, this has been a video on filling in tables. If there's any part that you didn't understand, please rewind, rewatch, and bring any questions to class. Thank you.